Objectives. At the end of the lesson, you should be able to 1. List all the factors of given numbers. 2. List the first few multiples of given numbers. 3. Determine the prime factorization of given numbers. Factors are numbers multiplied to result to a given number. Some numbers just have 1 and itself as its factors. Other numbers have more factors. As an example, the number 12 has 6 factors. Here are 2 more examples of numbers with several factors. 15 equals 1 times 15. Another multiplication that results to 15 is 3 times 5. 1 times 16 equals 16. 2 times 8 equals 16. 4 times 4 equals 16. Here are 2 more examples of numbers with just one pair of factors. 7 equals 1 times 7. 17 equals 1 times 17. Notice that there's no other way to rearrange these numbers of coins into rows with equal numbers of coins in each row. There's a special name for these kinds of numbers. They are called prime numbers. Their factors are just 1 and itself. The first 5 prime numbers are 2, 3, 5, 7, and 11. Let's now define multiples. The first 5 multiples of 2 are 2, 4, 6, 8, and 10. For the number 3, its first 5 multiples are 3, 6, 9, 12, and 15. With multiples, you can go on multiplying the given number beyond 5. Let's now list the first 5 multiples of 5 and of 8. The first 5 multiples of 5 are 5, 10, 15, 20, and 25. Great! The first 5 multiples of 8 are 8, 16, 24, 32, and 40. Examples. What is the 8th multiple of 6? 6 times 8 equals 48. You don't need to list all the lower multiples of 6. What is the 12th multiple of 7? 7 times 12 equals 84. Let's now discuss prime factorization. All numbers may be expressed as a product of several prime numbers. Let's do an example to explain this. Given the number 30, let's find its prime factorization. Start with writing down this multiplication whose answer is 30. 5 is already a prime number, while 6 is not, since 6 equals 2 times 3. 2 and 3 are both prime numbers. The prime factorization of 30 is therefore 30 equals 5 times 2 times 3. What you've just seen is the factor tree method for getting the prime factorization of a number. You can also do the continuous division method for prime factorization. 30 divided by 2 equals 15. 15 may be divided by 3, and the answer is 5. This therefore is the prime factorization of 30. 5 is already a prime number, and so we can stop dividing there. 30 equals 2 times 3 times 5. Let's do another example. Determine the prime factorization of 56. Let's do first the factor tree method. Start with showing that 56 equals 7 times 8. Since 7 is already a prime number, it doesn't grow any more branches. 8, however, is not a prime number. It branches out to 2 times 4. 2 is already a prime, while the 4 gets split up into 2 times 2. The prime factorization of 56 is therefore 56 equals to 7 times 2 times 2 times 2. We may simplify this further by using exponents. 56 equals to 7 times 2 to the third power. See how the same answer is arrived using the continuous division method. Let's practice. List all the factors of the following numbers: 24, 25, 25. Now, list the first three multiple of these same numbers, 24 and 25. Lastly, determine the prime factorizations of these same numbers, 24 and 25. For 24, its prime factorization is 24 equals 2 times 2 times 2 times 3. Simplifying this using exponents, 24 equals 2 to the third power times 3. For 25, it is a perfect square of 5, and 5 is already a prime number. Let us put all these together in one table. Notice that factors of a number are 1 and itself, and possibly some other numbers in between. The first multiple of a number is itself, and then the next multiples will be larger and larger. The prime factorization of a number shows the number as a product of all prime numbers. When a prime factor is used repeatedly, it may be expressed as in an exponent form. Remember, numbers have at least two factors, 1 and the number itself. Numbers that have only 1 and itself as its factors are called prime numbers. Numbers that have more than two factors are called composite numbers. Multiples of a number are obtained by multiplying a number by the counting numbers 1, 2, 3, 4, and so on. The prime factorization of a number shows the number as a product of all prime numbers. You may use the factor tree method or the continuous division method to get a number's prime factorization.